Hello, everyone, and welcome back to our next slots and next sessions within Big Data Days 2023. For our next session, we're going to be learning around detecting hidden UHNW customers in banking, the machine learning and big data approach. I have the great pleasure to introduce to you today Mohamed Bedia, who is the head of data analytics and BI at the M7 Group. Mohamed today is presenting from Luxembourg. Mohamed is currently the head of data analytics and BI at the M7 Group, a broadcast media production and distribution organization. He was also a manager in Deloitte's artificial intelligence and data department, where he leverages his expertise in data science and AI to drive meaningful business results. With a deep experience in the banking industry, he has applied a range of data analytics and machine learning techniques to build real-time data products that have delivered significant return on investment. In addition to his professional pursuits, Mohamed is deeply committed to using AI for the betterment of humanity. He has taught machine learning, applied statistics and coding, and has worked with African governments to develop AI strategies that address key social and economic challenges, such as youth unemployment. It's my great pleasure to welcome Mohamed for his first presentation at Big Data Days. Mohamed, it's really a true pleasure to have you today, and I'm sincerely looking forward to your session.
Thank you so much, Jan, for this nice introduction. So without further delay, we'll go start. So first of all, good afternoon or good morning, wherever you might be right now. And today we will walk you through a use case that I used in banking a couple of years ago now. The use case was about detecting ultra high net worth customers in banking using machine learning and big data approach. And the reason why I'm talking to you about these use cases specifically, I didn't choose it randomly, I wanted to walk you through all the burden, all the challenges that we face in banking. And I know that from my past experience in banking industry, that many banks are still facing it right now. And the goal of this presentation is to walk you through how we use that typical use case to get sponsorship and buy-in from our management executives to roll out our data governance and data overall strategy. So this is the discussion point. I will slightly give you an overview of the current AI banking landscape, and I will talk briefly about why banks need AI. Then we will discuss the barrier to adopting AI. What is a typical roadmap to adopt AI in banking? And then I will conclude with our use case. I will walk you through that use case. So if we look at today at the AI maturity for banking, we can segment them in 4 groups. If you use on the x-axis the AI capabilities and the y-axis the AI strategy, you can see that you have 4 groups. The top one, I would say, the AI achiever is 100. It's only 1% of banks today, and these groups are characterized by banks with a very strong AI strategy, and also with strong AI capabilities. And on the other hand side, you have 75% of banks that are today, we call them AI experimenters, meaning that they have low strategy about AI and low capabilities. And some of them, they not even started the AI journey yet. And then you have others. So what you have, the AI builders. So the AI builders is a company, banks characterized by the very strong foundations, AI capabilities, but very low AI strategy. So their AI capabilities exceed their AI strategy. And you have the innovators that are company that really investing in governance, data management, etc. So they are mature in terms of strategy, but they struggling to find use cases and to monetize their data. I would say they are in the good path, and the next step for them is to become AI achievers. So if we look at then at the AI maturity by industry, we can see that the banks, the banking sector is way behind sectors such as retail, for example, or tech, for example. So why banks are not that ahead? Because we will see it in the next slide. But the banks are having a lot of legacy system. They have tight regulations, etc. A panel of challenges that's making this ranking that we see today. So why do banks need AI? I think that now that's with the rise of a large language model, ChatGPT, now everyone is looking at AI from a new perspective. And I don't think that today there are CEOs that does not know about AI and why they need AI in banks. So that's why I'm not really will not talk a lot about this slide, but mainly if we look at the business model of a bank or any industry, you look at the goal is to focus on 5 areas. Well, first one is acquisition. We want to increase our customer. Second one is experience. So we want to enhance the experience of our customer. The third one is relationship. We want to develop the relationship with the customer and develop the business at the same time. For the number 4 is retention. We want to control churn and retain our customer. And number 5, we want to do all these steps with being able to compliant in the eyes of regulators. And AI can help banks in each one of these steps to enhance and develop and accelerate the development. So what are the barriers to AI adoption in banking, and why banks are really struggling to use AI? On one of the top, I would say, reason, you will see that there is a fragmented data and ownership. So data is siloed, and it's most of the time it's shuffled between IT, business, etc. And you can have a team working in the marketing department when they want to build, for example, a use case about advanced analytics or machine learning that really have a big, it's a quick win and big value, but they cannot do it because the data that they want is is another system or belongs to another department. There is no clear, I would say, governance on that. So that this is a big challenge in bank. And as someone who works in banks for almost 6 years, I know what I'm talking about. It's really a tough work. Second one is the absence of data culture and literacy. So I would say that historically banking industry was an industry where especially when you look at wealth management and private banking, the business was done based on I would say more on the not really rely on data, on how we monetize data, how we use it. It's about relationship with the customers. Well, I am a portfolio manager. I know this guy, I know this guy, and I know the family, so I can advise them better. And also customer, they really they prefer personal touch, personal contact with their portfolio manager, and so they can advise them. So data was not really a big subject until I would say beginning of 2000. And so that's why the employees working at banks lack of data culture and data literacy. The third point is poor data quality. This is also one of the biggest challenge. Poor data, because data is, I would say, shuffled in between multiple departments, and there is no clear architecture. There is no real good data governance put in place. We lack definition. Data sometimes is inaccurate, incomplete, and we don't know who is the owner of that particular data. So the result is that we have poor data quality. And the fourth point is manual dependencies. So this point is, I would say, the aggregation of the first three, because data is really quite inflexible, and we cannot acquire it in real time to do use cases, etc. So we have a heavy manual dependencies. Of course, there are other barriers to AI adoption, such as tight regulations, etc. But this is really, I would say, related to the country and the area where the bank is. For example, in Europe, GDPR or BCPC 266, it's really giving I would say, the AI and data analytics team cannot use data really quickly because they have to walk through a very heavy manual process that is sometimes not clear and well defined. So that being said, what is a typical roadmap then to adopt AI in banks? So if you look at, I would say, uh, basics, good practice in data management, such as the DAMA book, for example, or approaches from big consulting companies, Deloitte, or even if you look at Gartner, for example, you will find these components most of the time. And the first one is to build a data strategy. So you need to build a data strategy, you define your data objective and align them with your business goal, and then you prioritize it. Once you establish the data strategy, then you need to have a data governance. So data governance is very linked to the data strategy and the data architecture. It's a way that will establish data policies. You define role and responsibility. Who is the owner of which data? You define the data quality process, compliance, etc., so that people that will use data will use it in a very smooth and I would say a good environment. And once you've established these 3 points, data architecture, now people go to talk about data lake warehouse or data lake, etc. Then there is the data monetization, which is for me the central, I would say the key element of this roadmap. Because at the end of the day, if you do all these, you invest in a strategy, governance, etc., your goal is to monetize your data. So this data monetization should drive, I would say, all this roadmap. Then once you establish the data monetization, you identify the use cases that you have, and then you rank them based on feasibility and business impact. Then you have your list of data monetization use case. Then you start implementing them, and you have also the data literacy. You would need to go walk through your staff about data, talk them about data literacy, especially at the executive level, but also at the operational level. And you do continuous monitoring here. What you track the use case that you implemented, you see the return on investment, you maintain data quality governance, etc. And then last step is innovation. You really need to encourage experimentation, innovation, etc. Now, this is on a theoretical level, and what I see is that many banks struggle with this, not because they don't know it. Of course, they have this roadmap, they know each component, but the problem is, I would say, they fall into a waterfall trap, meaning that they think that they need to have each one of these components in order to start doing monetization or to get value of the data. And that's why sometimes it's really challenging, because if you are at the executive level and you invest a lot of money, because here data governance and data architecture, we're talking about millions in terms of investment, and you don't see the value of it in the next 6 months, or I would say the next year, it's really hard. And I understand the position of executive at this level, and that's why it's really tricky when you talk about AI adoption in banking, because most of the time CEOs or executive, they don't see value of data monetization. They don't see quick wins, I would say, using this approach. And that's why the wise way to do it is to do it by iteration in an agile way, meaning that first you identify a use case, let's say 1, 2, 3 use cases that are super relevant and you can do in a very quick time. And then you define the data that you would use, etc. So then you identify, you roll out the governance and data architecture only in the scope of these use cases, and then you iterate every time so that you covered as much as use case possible. And why doing this approach? Because you can deliver quick value to the executive, to show them that you're on the right track, that is you're already making an impact, and then naturally, the more use cases you will have, the more value you will bring to the company. That's why I titled the name of this presentation, detecting high ultra network net worth customer, because it is a typical use case that we use. We were in the same dilemma. We had all the problem that I showed you before, and we wanted to implement a proper data governance. We wanted to move from I would say standard data warehouse to more Snowflake, data lake, etc. And even though the management on some level were willing to invest in this, but we had to bring them, show them value for this. So we identify one use case, which was the one that we'll talk you about right now. And then we show them the results so that we get the buy-in from them. They're really confident about it. And then we start rolling the governance, the architecture, and the strategy by iteration. So back to the use case that I wanted to present to you. So this use case is about detecting a hidden ultra high net worth customer. So if I give you a bit more context, the bank that I was working for was the leader in France, and I think that one of the top 10 worldwide. And the region that I was working for, we had, I would say, one customer over two was already client in our bank. So keeping customer acquisition in a traditional way was really hard, because we reach a certain limit, and we have to think about we have to think outside the box about way of optimizing the portfolio and keeping acquiring customer, and developing our net banking income. And then we said, okay, we have this large segment of, I would say, a low income segment. Well, low income segment is really relative about how much you're talking about, but in our case here we call it low income segment. And basically we use a traditional segmentation that is based on I would say transaction movement, financial transaction, and savings. So this is traditional segmentation that's used by many banks, especially in the retail, even though here in our case we are in the retail bank, but with this private bank subsidiaries. And our goal here was to make a zoom on this low income customer and try to find some hidden ultra high net worth customers. The hypothesis that we made is that when you are a customer in our bank in low segment are using our bank as a secondary bank, then we don't know where your true potential. Your true potential is hidden for us, because we don't capture all the transaction you do. We don't capture all your saving. You only capture what you are sharing with us, and we might have hidden ultra high net worth customers here. And so our approach was to develop an innovative machine learning algorithm, and to try to analyze many data, except those data that we use for segmentation, because obviously they will naturally classify those customers as low income. So we have to get rid of this data and find new data, and really rely also on open source data, which was I would say, the key element in our approach. And as I mentioned, our goal was to detect pattern and similarities between these hidden ultra high network customer and our existing ultra high network customer. So if we found patterns and similarity between them, and then we know that these guys are segmented are low income, so we don't know their true potential. And we had another approach. I will tell you about it, how to assess the veracity and the truth of our model. So if we go to the challenges that we encountered while building this use case, well, first, of course, when you work in banks, it's the challenge number one, especially when you work in data science. It's a regulatory compliance. So we had to really prove that we are not intrusive on the way the data that we use. We're not collecting personal data, and the way we use data is on aggregated level, so that we are not intrusive in the life of our customers. So that one was really challenging, because it's always a trade-off that you need to balance. And then the second point was data quality and completeness. So we had a lot of data quality issues, and inconsistencies. That was a very, very big challenge. And the third point was the integration of diverse data source. So we wanted to look at I would say the location of our customer. One of the assumptions that we made is that you may call it a dumb assumption, but rich people, wealthy people, tend to live close to each other. And so we know where our customer lives, and we need to find open data that we can, I would say, scan our challenge. We call it challenges in France, in French, which is our market zone, where we can identify the very rich area where wealthy customers, ultra high net worth customer lives, and to segment them. And so we had to rely on open data for that. And also managing this open data and integrated with our existing data was a bit of a challenge. And then the last point was building the model, because building a model is something. Having a machine learning model that is really good, have a very good accuracy, recall, whatever metric you want to choose, is something. But building a model that you can that stakeholders and business person can understand, this is a completely different challenge. So we had to rely on I would say understandable and explainable machine learning framework, so that we can explain to business person why the algorithm is classifying a given customer as a ultra high net worth, a potential ultra high net worth customer. And that being said, we had also to work very closely with the business to find out about strategies, because identifying those customers is one thing, but convince them to become our customer is a completely different thing. So we have to come up with strategies, scenarios where we can contact those guys and convince them to bring their savings from another bank to our bank. And that was also a very difficult challenge. So talking about the solution, so as I mentioned, we collected really diverse data, open data. So we were able to, I will show you in a bit how we've done that. But here the goal is to show you the bigger steps of our solution. So we identified those areas with high concentration income of people. And also we used data such as swimming pools, because we found that the area where you have ultra high net worth customers is often an area where you have a concentration of swimming pools. So using open data, satellite image data, we were able to identify those areas. And also using the KYC data was a crucial part, because when in France, whenever you open an account, even if using it as a secondary account, you need to bring data about your I would say tax information, and that data was stored and never used. It was there, and so we have to use NLP to extract the information of it and use it. And so by combining these diverse data, we're able to had a very good data set that we can use now for machine learning. In terms of machine learning, we use the classic machine learning, a strong one, is still strong now till today, XGBoost algorithm, and combined with a spatial data. And we come up also, we worked very, the development of the solution took us around 3-4 months, but the strategy took us also approximately the same time. We had to work with the marketing and commercial team to create marketing materials based on some of the foundings that we had, but also based on the commercial team knowledge, because we bring on the table the list of these potential customers, but we had to validate it by commercial people with really a heavy business knowledge. So we work together and we come up with a script and marketing materials. And then we built a tracking tool where we measure the performance of the action. Whenever we call someone, we know was it really precise. The prediction was precise. What was the discussion between the portfolio manager and the customer, and etc. So a lot of metrics that we were following to measure the success of the action. And this is an example. I put a big fake here so that you know that what I'm showing to you is a big fake data, because for confidentiality reason, of course, I cannot show you the data that we had at that time. But it is an illustration. So on the right side, you can see, for example, this is a mapping of a village or an area, because we were in a very big area, and about I would say 5 million customers. And this is a scan of a village that we had. And so when we apply, when we use open data, and from INSEE, which is the statistical, the equivalent of Bureau of Statistics at the United States. We used OpenStreetMap, Google Maps, and using Python and R, we were able to do this, I would say, segmentation. So the red area are the area where you have a concentration, where you have a very high income customers. And how we are doing this, we are collecting data for open source, as I mentioned, from INSEE, and they already have a data set shapefile where they map all the France territory into small boxes of 200-meter side that you see here. And for each square, they have a lot of statistics: how many people are living there, what is the average amount they have declared for tax, the educational level, etc. So we managed to use all these data, and we come up with this cartography segmentation that mapping that you see here. The more red the square is, the more rich people live in that area. And so when it was also a powerful tool for our commercial team, because they can really spot false positive, true positive, whenever we give them a subset of the customer inside their portfolio. If I give you an example, then the algorithm we know the location of our customer, and so once we do the machine learning training, we score the customer, and we plot only the customer that are with a good scoring. For example, here and here, you can see, so these are customers that are segmented as low income, but they live in this rich area. And due to the metrics that we have done, you can see that there is an anomaly here, because due to the high price of the meter square, which is one of the data points that we used, and due to the income of these people, supposed income, it's really hard to imagine that they live in this area. So there was an anomaly here, and this is making us confident with the scoring that we have. So it's typical of true positive. On the other side, we have people that you can see here in the yellow square. So yellow, very yellow, mean that this is a kind of poor area. And this is whenever we score someone and we put it here, then it's, of course, it's a false positive, because an ultra high net worth is unlikely to live in such area. So of course, this is just an illustration of the output. So as I mentioned, I cannot show you the real data, but it's really how it looks like. And so the team from the commercial team and the marketing team also, they worked with us in a workshop where they validated for each a portfolio manager. A portfolio manager is managing about sometimes 400 to 100 to 400 customers, depending on the level of seniority. So they were able to tell us if our findings and the algorithm was doing some good stuff. So this is one of the validation way we used. And the results, the important part, you will say. So quickly, we had a very high conversion rate. Surprisingly, we achieved 37% conversion rate, meaning that we come up with an identified list, let's say 1,000 customer, we share it with portfolio manager, and so among the people that they contacted and they were able to touch, the conversion rate was 37%, which was huge for us, because our classical marketing campaign conversion rate is around 15 to 20%. And this conversion rate, we were able to see it immediately on the portal that we were using, and it was something very, I would say, fantastic, because you see a guy that is low income that was contacted by a customer. You see the script or the discussion they had, and you track this guy 2 months later. You see that he's bringing hundreds of thousands of euros, sometimes millions, as a savings. So he's swapping from his last bank to old bank to our bank, and of course that because of the marketing offer that we made, we had to come up with. Second point was time efficiencies. So while doing this use case, we documented each steps and each challenge that we have, because we wanted to illustrate to our executive, okay, you see this is a typical good use case with a high ROI, return on investment, but you see that our time to market was very, I would say, not perfect. And once we implement a data strategy, or we roll out the data roadmap, then our time to market will drastically be reduced, because we will not have data quality issues, we will not have governance issues, and the architecture that we will use will be much more robust than the legacy architecture that we are using. And that leads to a buy-in from the executive. So we had a committee where each month we were looking at the conversion rate, the success of the action, around like 4 to 6 months, and they were really happy about it, and that's convinced them to give us the sponsorship to roll out the data governance. So of course we had to identify other use case, and that's where we keep rolling the data roadmap step by step. And last point was the team expansion, which is a bit funny, because when we were building this use case, at that time we were about 3 data scientists and 1 data analyst, and that team grew by 250 over the next 2 years. We had a very large team, and we hired also, I would say, digital marketers with web analytics background in our team, because of other use cases and because we were able to show to the management the impact of such use case. So that's bring me to the end of my presentation. I hope you enjoyed it, and I hope there is a question. Feel free to ask if you have any question.
Good. Thank you so much, Mohamed. This was a very interesting use case. What I always like around these sessions is that it's really data science and machine learning in practice. And I think what you've shown is a really interesting use case, and with some very clear results. Obviously, with a use case like this, there's quite a lot of questions around how do you deal with certain aspects. So I'd like to start with moderating some of the questions that came in. The first question that came in was from Jean-Paul Karangwa. And the question is, in your efforts to detect these hidden ultra-high net worth users, what was your primary goal? And did you think of any case of intruders who could benefit from this network or from this research?
Okay, so the primary goal, as I said, was to optimize the portfolio and also keep increasing the customer acquisition. As I mentioned, we reached a level where one over 2 of customers, 50% of the inhabitants of the area were already our client. So it was really hard to keep increasing it. So I have to come up with a clever way to boost our net banking income. So increasing the net banking income was our primary goal, I would say here. And for the last part of the question, I think I didn't understood what was the...
Yeah, so I think the question is, what if this kind of data falls into the wrong hands? Because as you can imagine, and I think that this is what the question is kind of leaning towards, is this information could also have risks for maybe let's say burglaries or other kind of criminal behavior, because banks are not the only people interested in these ultra high net worth individuals. Let me put it that way.
Oh, okay, yeah, no, cool. Thank you for explaining me. So yeah, this data, as I mentioned, is an open source data, and it's at aggregation at the aggregated level. So the INSEE, the owner of this data set, is using a statistical method, windsoring, and this kind of statistical method, so that you're not able to identify customers for people in the area of 200 square meter aside. They give you the average income, the average level of education. So it's aggregated, so and anonymized, I would say.
Good. So on that, and that's more of a question from my side, is what kind of checks and balances do you need to tackle when going through a process like that? Because I can imagine there's a lot of customer sensitive data from the bank. There's also all kinds of regulations, both from a government or maybe even internal policies that you would need to do. Do you have some kind of a process that you go through in order to bring a solution like this to market?
Yeah, of course. So as I mentioned, we in the banking industry, we really, especially in Europe, we have to deal with GDPR and other regulation. So everything that come out in our lab, our experimental lab, has to be validated by the CDO. And we have a process. Every time we use a typical data point, we need to justify why are we using it. Is it for the customer? I would say good or not. And also when it comes to data such as transactional data, we cannot use it at personal level. So that's why we come up with aggregation. We don't track the customer, we track a group of customer. So in that way, this is anonymized.
Very interesting. And just out of my personal interest, do you then use a specific code book, or how do you validate that? Is there some kind of a document that you need to present, or is it embedded within your software tools? How do you do that?
Well, in terms of software, we were using open sources. We're using Python in R. At that time, we were using AWS, our infrastructure, but we moved to Snowflake in terms of presentation, it's really hard because here we do assumption on hidden ultra high net worth customer, and that's why and I think that's what makes this as a successful project, because we involve the business in the validation process. Usually when we do machine learning model, when we label the data, we tend to rely on data scientists to do that. For here, we really had to rely on business team expertise that help us not only for the labeling process, but also for the validation. When we come up with the first batch of results, they were able to tell us, okay, this one I don't think it's a good, and then it was an iteration process.
Good, interesting. Good. Then I like to moderate some more questions that came in. Let me put them on the screen. The first one is the question: Hi, sir. I would like to ask if this kind of solution is more suitable for newly formed companies instead of existing companies, because it is involving a lot of funds, investment training, and business process change. Do you think you're obviously at that time were working for a large bank at that time? Do you think this could be used in a startup environment as well, or do they miss the data to kind of build solutions like this?
Oh, definitely. Actually, I get the idea about this when I was attending a seminar with the startups. So definitely it can be done with startups. And I currently, even though I've done a shift in my career, and now I'm in a media streaming group, but this is kind of techniques that we really can apply also to understand, because as I mentioned here, we look at it from the prism of incomes. That what these guys are paying to the government as tax. So we're able to remember the red boxes. We're able to build that based on that. But another use case can be, I want to target, let's say, area where we have more female than male, for example, or any kind of thing that you can imagine.
Interesting. You're kind of already bringing me towards the next question. which is from Wilson, and he is asking any other real-life case that you utilize machine learning and big data in the banking industry. So I think he's inspired to learn a little bit more.
Well, another use case where we use machine learning, for example, it was in the simulators. We have some simulators on our website. So whenever you are looking for a mortgage or a consumer credit, you do some, you put some information about you, and there is a slider that you play with it, and then you will have information about how we can sell you this credit, etc. And so what we noticed is that the drop-down people, the people that go to step number 3 and then they leave because in order to be able to be contacted by the call center, you need to finish 4 steps. They will contact you, they will tell you, okay, we've seen that you've done the simulation, let's discuss about your credit offer. But we noticed that a lot of these people drop at the step 2 or step 3. They never go to step. So here we had to do a real-time machine learning. So whenever they dropped, we used real data to assess the potential of paying and the similarity of the people that for whom we give this credit, and we call them in the next 2 hours. So this is sent to the call center. We tell them, okay, these guys went to step number 3, but they left. If they went to step 3, there is a high probability that they are willing to contract the credits. Let's call them. And using that also, we were able to have a high return on investment.
Very good. Thanks, Mohamed. You kind of answered all the questions. I thought this was a very cool and interesting use case. I would love to see the real data models behind it, because I think there is a lot more work than just the outcomes of this result. So I think it's a very interesting and cool use case. So thank you so much for being part of Big Data Days 2023. Hope you enjoyed your first time presenting with us. And thanks so much for sharing your story.
Thank you so much, Jan, and thank you for giving me the opportunity. I really enjoyed doing this presentation.
Good. Thanks so much. Let me quickly show everyone what is going to happen in 20 minutes from now. Good. Our next presenters are already in the waiting room, and on the next hour we will have 2 very interesting sessions again. We're going to get started on track 1. We have Hani. Hani is the Chief Data and Behavioral Scientist at iSight Tech, and he is going to be talking about cracking the cultural code through behavioral science and data analytics, which I think is a really interesting and cool topic. On track number 2, we have Pratnya Chavan, who's the Manager at Strategic Projects and Operations at Verisk Analytics. And she's going to talk about how project operations are holding back innovations and what you can do about that. So again, difficult choice to make, but take your pick, and we will see you back in 18 minutes from now. Thanks, everyone.